According to a preliminary assessment of solid waste in the Philippines, 25.57% of waste composition consists paper. However, only 20 to 33% of paper waste is being recycled.
Food waste is a persistent issue in our country as shown in the graph based on the expanded National Nutrition Survey. Rice, vegetables, and meat are the top 3 most wasted food among the Filipino household. Among vegetables, malunggay, Moringa oleifera stems are often considered as food waste despite the nutritional value they contain. This perception is due to their irrelevance in cookery.
By combining two things that are considered as waste, the researcher was able to produce something new. Handmade printing paper, exploring malunggay, Moringa oleifera stems as primary component for environmental sustainability. The general purpose of this study is to develop a handmade printing paper with malunggay stems as the primary component. Moving on to the chapter 2 of this research study, which involves the methodology. The researcher used 70 grams of malunggay stems with recycled paper from old notebooks and 260 grams of cornstarch. The authenticity of the malunggay stems were confirmed by the Bureau of Plant Industry. Following a specific procedure, the researcher boiled the malunggay stems in distilled water with sodium hydroxide to remove impurities and to soften them for 1 hour. Simultaneously, the researcher shredded paper and soaked it in the paper for 2 hours to prepare it for blending. The researcher filled a blender with 250 ml of water and blended the freshly boiled malunggay stems for 3 minutes. The researcher added 30 grams of recycled paper, 2 tablespoons of cornstarch, and 7 grams of chlorine, blending the mixture for an additional 1 minute until the pulp became white and free from visible malunggay fibers. After preparing the pulp mixture, the researcher filled the container with water and blended the pulp into it. Then, the researcher used a molding decal to evenly distribute the pulp mixture. Finally, the produced paper was sun-dried for 24 hours outdoor. Then, the researcher conducted the tear strength, tensile strength, and the castor oil penetration test at the Department of Science Technology, Forest Product Research and Development Institute in Los Baños, Laguna. Chapter 3, Results and Discussion. Table 1 provides the insight to the tensile and tear index values for the handmade paper. Notably, the high tensile index value of 11.248 Newton per meter signifies the substantial resistance to stretching or pulling, making it vulnerable for numerous practical applications. Furthermore, the tear index of 9.505 millinewton per square meters, making it well suited for a wide range of general purpose applications that required moderate tear strength. Based on the data presented on the table, the bottom side absorbed the applied oil in a remarkably short time of 35.664 seconds, indicating its high absorbency. In contrast, the top side absorbed the oil in 50.736 seconds, suggesting its lower absorbency or greater resistance to oil compared to the bottom. The ISO 1924 tensile strength test showed that the handmade paper has a high tensile index value of 11.248 Newton per meter, indicating its ability to withstand stretching and pulling forces. In comparison, commercial paper broke at 9 Newton per meter, while the handmade paper held up until 11.248 Newton per meter. The significant difference in the tear strength between the handmade and the commercial paper leads to the rejection of the null hypothesis in the favor of the alternative. The handmade paper exhibits reasonable tear-resistant qualities with an average tear index of 9.50, positioning it in the middle of tear-resistant spectrum. Its low standard deviation of 0.941 indicates its consistent performance, making it suitable for various general-purpose applications that require a reasonable level of tear resistance. The commercially available paper showed a superior oil resistance with a value of 60 Newton per meter on both of its top and bottom surfaces, surpassing the handmade paper, which recorded values of 50.74 Newton per meter on the top surface and 35.664 Newton per meter on the bottom surface. However, in terms of tensile and tear properties, the handmade paper outperforms the commercial standards, demonstrating excellent performance.